Hi everyone, Nathan here from G2CPU. We've been away the last 6 months working tirelessly on the upcoming version of G2CPU, which is going to be all about GPU side rendering of graphs. Now that this version is almost complete and almost ready to be sent out, we're going to pick up these tips and tricks videos once again for you, so you can get the absolute most out of GPU computing within LabVIEW. Now, a really important part of GPU computing is, well, sending data back and forth from the GPU to our LabVIEW environment. Now, with this video, I specifically want to focus on getting data from the GPU back into LabVIEW. This is, for example, useful when we're simulating data to stress test our CPU, or just general simulation, or we, for example, send the data to the GPU. We've done our FFTs, feature detection, and so on, and we want to get our results back into LabVIEW to store them to disk, to perform certain actions based on them, or whatever you need to have done. Now, to get started with this, we're going to have a look at this block diagram. So what we're first going to do is we're going to initialize our G2CPU environment. This is going to load in all the CUDA drivers, all the OpenCL drivers, depending on which technology you're using, and it's going to make sure everything's loaded in before we're actually going to do our calculations. Now, this is not 100% necessary, but it's going to improve your calculations, especially during the first few iterations of your algorithms. So after we've done the initialization, we're going to go into our while loop, our program. What we're going to do is we're going to generate 100 megasamples of sound wave with some noise added on top of it. All of this is done completely on the GPU. And after this data is generated, we're going to download the array, the complete 100 mega samples, to LabVIEW, after which we're going to do a small operation just to check, hey, is there some data? Now, of course, in real life, in your application, you're going to store this to disk, you're going to show this in a graph, you're going to do your own calculations or decision making on top of this, but this is just to keep it nice and simple. Now, downloading here in the most simplest form when we press play seems to go quite slow. We're hitting about 3 gigabytes per second of purely sending the data from the GPU to the CPU. Now, this is not amazing. So let's see how we can improve this. Well, in the latest versions of G2CPU, some alterations have been made. Now, you can actually provide a function with a pre-allocated buffer, an array, which is already being generated or has already been generated. So the function doesn't have to go to Windows and say, hey, can I get some more memory? No. The memory is already there, so no time to waste on that, which often is actually proportional to the amount of data that you, or the amount of memory that you need. So if we can use this, great. Now, the easiest way to use this is, for example, with feedback nodes or shift registers. So what we can do here is say, hey, I allocated some memory, put it in a shift register, and since it's already allocated, I can just provide it back once again. And of course, let's make sure our shift register is initialized on startup, otherwise it's going to act as a DVR. And so what's going to happen is, this empty array is going to be provided in here. And what the function is going to do is say, hey, how much elements are in this array? Are there enough compared to the amount that are available from the GPU? If these sizes match, great, then G2CPU will just send the data into that array. Now, if there isn't enough space within that array, or there's too much space, what G2CPU is going to do is say, hey, I'm going to allocate it once again because it just doesn't match. So it's going to take a little bit more time. But this allocation is only once. After the allocation has been done, we can reuse and yeah, we can go at full speed. So let's try this. Let's run this. And we're already seeing quite some improvement. 13 gigabytes per second. Wow, that's amazing. Even our loop rate went up to about 30 sine waves per second, which please keep in mind is 100 mega samples. So in this case, we're generating about 3 gigasamples per second, purely simulation data, all on the GPU without actually taxing the CPU. Now, these types of buffer allocations done via LabVIEW can sometimes be hard to maintain. Now, for this, LabVIEW has data value references, which we can actually also use. And for this, I made a completely different block diagram, which looks something like this. Now, straight off the bat, you're going to notice there are some minor differences. The array data constant, or just the constant array, is no longer fed directly into the shift register. Rather, it's being fed into a new data value reference block, which is going to pin the memory for us so that we can reuse it whenever we want it, rather than letting the LabVIEW memory manager take control of it. So what's going to happen is, during the first iteration, when we're downloading the array, this array is still empty because, well, we defined it that way in the array constant. So what G2CPU is going to do is say, hey, I have 100 megasamples, but you're providing me an array with 0 samples. I'm going to allocate some memory for you, which you can then afterwards put into that data value reference, which you can see here. So this will contain 100 megasamples or 100 array indexes, which are then written into that data value reference. Now, after it has been written, we can then say, hey, look, do our CPU algorithm through this in-place element. In this case, again, just a simple index, but you can save the file. You can feed the DVR directly into some functions without any issue. Now, after that's done, in the next iteration, we're going to generate a new sine wave. This array is already going to be pre-allocated with the correct size because, well, the 100 megasamples hasn't changed. And instead of wasting time asking the operating system, hey, can I get some more memory? It's going to happen in a blink of an eye once again. So if we click play, you can see here, we're hitting 12, 13 gigabytes per second with ease, almost exactly the same as the previous block diagram, which means we can get this amazing performance with both simple functions, simple blocks, to more complex programs which need the use of these data value references. Now, I hope you found this video interesting. If you want to get started with GPU computing yourself, you can do so for free using the G2CPU Community Edition, which you can freely download from VIPM. Should you want to use GPU computing in commercial or industrial applications, there is a commercial edition available that you can also download via VIPM. Now, if there are any topics you want to see in an upcoming tips and tricks video, feel free to reach out to us at info@G2CPU or just comment beneath this video. Thank you very much, and we'll see you next time. Bye!